This is Spring Review three's homework on Riemann sums. And let's look at the first for response here. This is from 1996, number 3. The rate of consumption of cola in the U.S. is given by S of t is equal to CE to the KT, where S is measured in billions of gallons per year and T is measured in years from beginning in 1980. Okay. So for part A, the consumption rate doubles every 5 years, and the consumption rate at the beginning of 1980 was 6 billion gallons per year. Find C and K. So we have to go through uh, essentially the differential equation process, except now we know we need to separate the variables. We just have to plug in and solve for C and K. So what I like to do is I like to set up and identify the order pairs that we're plugging in. So uh, uh, time is the independent, and the dependent is the consumption rate of cola. So at time t equals 0, and we're going to let t equals 0 represent 1980. At t equals 0, consumption rate is 6 billion gallons per year. Consumption at 5 years later, okay, because we see that doubles every 5 years. So 1985, 5 years later, the consumption is going to double to 12 billion gallons per year. And so we can use this information to solve for C and to solve for K. We like to have the plug in the order pair that has the 0 first, because that will cancel out nicely. So plug 6 in for S of t, plug 0 in for time, and then the e to the k times 0 will go to 1, so C is equal to 6. So our next step, we have C value found, so S of t is equal to 6e to the kt. Next, we can plug in the other order pair, 5, 12, to find our k value. So 12 goes in for S, and 5 goes in for T. And then 6e to the k times 5 is equal to 12. We want to solve for k, but we want to first move things to the other side. So let's move the 6 over. 12 divided by 6 is 2. 2 is equal to e to the 5k. Take the natural log of both sides, because we want to find a way to bring that k down in front. This becomes 5k. So natural log of 2 is equal to 5k. Divide both sides by 5. We get k is equal to 1/5 natural log of 2. So we have our specific equation being 6e to the 1/5 ln of 2 times t. Okay, part B, find the average rate of consumption of cola over the 10-year time period beginning in 1983. So that means the 10-year period will be from 1983 to 1993. And if we want to find the average rate of consumption, we have the consumption formula, consumption rate equation given by S of t. If we want to find the average rate of this function, we're going to have to find the definite integral and go through average value theorem. So to recall, average value theorem is 1 over b minus a, definite integral from a to b of our function, in this case our consumption rate equation or function. And we're going from 1983 to 1993, and we know that 0 represents 1980, so we must be going from 3 to 13, right? We want to use numbers that are representative and easy for us to plug in. So if we use 0 for 1980, we'll use 3 for 1983. So then 1 over b minus a from a to b of our function. So all this can just be plugged in our calculator. And remember, this is in terms of billion of gallons. So 19.68 billion gallons per year, okay, is the average consumption rate, okay, over the 10-year period. All right, part C, use the trapezoidal rule with 4 equal subdivisions to estimate the definite integral of S of t from 5 to 7. So we know that 5 represents 1985, 7 represents 1987, and so this will probably, we're trying to estimate the total consumption of in gallons from 1985 to 1987. So we want to use trapezoidal rule with force equal subintervals. So that means we want to find the n value. So n value is b minus a over n. Width is b minus a over n. And our a and b values are 7 and 5. And our width, or our interval, is at 4. So 7 minus 5 over 4 is 2/4, or 1/2. So we want increments of 1/2. Okay. And our trapezoidal rule is width over 2 times h sub 1 plus 2h sub 2 plus 2h sub 3 plus 2h sub 4 plus h sub 5. And we can go through trapezoidal rule only because now we have a width that is consistent or the same throughout. So in our formula, it's simply going to be width over 2, or 0.5 over 2, times, and then we plug all these values in. S sub 5, S sub 5.5, S sub 6, S sub 6.5, and S sub 7, and then we can multiply 2 all the way through. And this should be sufficient, as there's no need to simplify, so this will get us to our answer. So if we were plugging all these values in our calculator, we'll get a numeric value that represents the total consumption from 1985 to 1987. So that's what part D is saying. The total consumption is if we take the accumulation or the integral of the rate of consumption, then what we're going to get out of it is the total consumption in those 2 years.